Yes, there is a code violation in having an accessible junction box with the feeder wires for a subpanel are spliced. This is because the neutral and ground wires should not be spliced within a junction box. According to the National Electrical Code section 250.64, c. The neutral and ground wires must be continuous from the service entrance to the equipment grounds. A splice would create a break in this continuity. The ground wire between the main and subpanel is an equipment grounding conductor, often abbreviated as EGC, not a service entrance grounding conductor, often abbreviated as SEC. A service entrance grounding conductor is required to be continuous, but an equipment grounding conductor is not. However, splicing the equipment grounding conductor in an accessible junction box could still compromise its integrity. Therefore, the feeder wires for the subpanel should be run continuously without splices in junction boxes. If a splice is necessary, it must be made using a listed splice kit and installed in a concealed location. Yes, it is code compliant to have a dedicated 20 amps outlet for a clothes washer in a laundry room. The NEC requires dedicated outlets for laundry appliances such as clothes washers and electric dryers according to NEC sections 210.11, C1 and 210.10. All other outlets in the laundry room can be 15 amps. Let's delve deeper into the specifics. When installing a subpanel, several key considerations must be addressed to ensure safety and code compliance. The feeder wires, which supply power to the subpanel from the main panel, require careful attention, particularly regarding splicing. According to the NEC, the neutral and ground wires should maintain continuity throughout their run. Splicing these wires within an accessible junction box introduces a potential point of failure and a violation of Code Section 250.64. C. This section mandates that the neutral and ground wires remain continuous from the service entrance to the equipment grounds, preventing any breaks in their conductive path. A splice essentially creates such a break, compromising the integrity of the grounding system. It's important to distinguish between a service entrance grounding conductor and an equipment grounding conductor. While a service entrance grounding conductor must be continuous, an equipment grounding conductor, which is the ground wire running between the main and subpanel, doesn't have the same strict requirement for uninterrupted continuity. However, splicing the equipment grounding conductor in an accessible junction box can still negatively impact its effectiveness. A compromised equipment grounding conductor may not be able to adequately handle fault currents, increasing the risk of electrical shock or fire. To avoid these issues, the ideal approach is to run the feeder wires continuously from the main panel to the subpanel without any splices in junction boxes. This ensures an uninterrupted path for both the neutral and ground conductors, maintaining the integrity of the grounding system. In situations where splicing is unavoidable, strict adherence to code requirements is essential. The splice must be performed using a listed splice kit specifically designed and approved for this purpose. Furthermore, the splice must be concealed within a location that is not readily accessible. This helps protect the splice from physical damage and prevents unauthorized tampering. Now let's shift our focus to the requirements for outlets in a laundry room. The NEC mandates a dedicated 20 amps outlet for a clothes washer. This requirement is outlined in NEC sections 210.11, C1 and 210.10. A, which specify dedicated circuits for laundry appliances like clothes washers and electric dryers. The rationale behind this requirement is to ensure that these appliances have sufficient power and to prevent overloading of general-purpose circuits. Clothes washers often draw a significant amount of current, especially during their spin cycle. Connecting a clothes washer to a general-purpose circuit could potentially overload the circuit, causing the circuit breaker to trip or, in more severe cases, leading to overheating and fire hazards. By providing a dedicated 20 amps outlet, the clothes washer has its own circuit with adequate capacity, minimizing the risk of overloading. While a dedicated 20 amps outlet is required for the clothes washer, the remaining outlets in the laundry room can be 15 amps outlets. These outlets can be used for other small appliances or devices that may be used in the laundry room, such as irons, steamers, or charging stations. It's important to note that even though these outlets can be 15 amps, they should still be installed in accordance with all applicable electrical codes and safety standards. This includes using properly sized wiring, grounding the outlets correctly, and ensuring that the outlets are protected by a ground fault circuit interrupter, often abbreviated as GFCI if required by local codes. In summary, when installing a subpanel, avoid splicing the neutral and ground wires in accessible junction boxes to maintain the integrity of the grounding system. Run the feeder wires continuously whenever possible, and if splicing is necessary, use a listed splice kit in a concealed location. For laundry rooms, provide a dedicated 20 amps outlet for the clothes washer and ensure that all outlets are installed in accordance with electrical codes and safety standards. These practices will help ensure a safe and compliant electrical installation. Let's break down the subpanel wiring further. When dealing with subpanels, understanding the role of the equipment grounding conductor is critical. This conductor provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers to trip and clear the fault. Continuous, properly sized equipment grounding conductor is essential for safety. Splicing this conductor, even in a junction box, can introduce impedance and reduce its effectiveness. While the NEC doesn't explicitly prohibit splicing equipment grounding conductors, it strongly encourages continuous runs. If a splice is unavoidable, it must be made using approved methods that maintain the integrity of the conductor. This typically involves using compression connectors or other listed splicing devices that provide a secure and reliable connection. Furthermore, the junction box housing the splice must be properly grounded to ensure continuity of the grounding system. The size of the equipment grounding conductor is determined by the size of the ungrounded conductors feeding the subpanel, as specified in NEC Table 250.122. It's crucial to select the correct size to ensure adequate fault current carrying capacity. For example, if the ungrounded conductors are 100 amps, the equipment grounding conductor must be at least number 8 copper or number 6 aluminum. Another important aspect of subpanel wiring is the separation of neutral and ground conductors at the subpanel. This is a fundamental requirement for separately derived systems, which include subpanels fed from a main panel. At the main panel, the neutral and ground conductors are bonded together, providing a single point of connection to earth. However, at the subpanel, this bond must be removed to prevent circulating currents on the equipment grounding conductors. These circulating currents can create voltage drops and increase the risk of electrical noise and interference. To separate the neutral and ground conductors at the subpanel, the neutral busbar must be isolated from the subpanel enclosure. This is typically achieved by using insulated standoffs or other non-conductive mounting hardware. The equipment grounding conductors are then connected to a separate ground busbar that is bonded to the subpanel enclosure and connected to the grounding electrode system, which consists of ground rods or other grounding electrodes. Moving on to laundry room outlets, the dedicated 20 amp circuit for the clothes washer is a critical safety measure. Clothes washers, especially those with electric heaters, can draw a significant amount of current, often exceeding the capacity of a typical 15 amp circuit. By providing a dedicated 20 amp circuit, the clothes washer has its own power supply, minimizing the risk of overloading and tripping the circuit breaker. The dedicated circuit must be wired with number 12 American wire gauge or larger conductors, and it must be protected by a 20 amp circuit breaker. The outlet itself must also be rated for 20 amps, and it should be of the grounding type. In addition to the dedicated circuit for the clothes washer, laundry rooms often require ground fault circuit interrupter protection for all receptacles within a certain distance of sinks or other water sources. This requirement is intended to protect against electrical shock hazards in damp or wet locations. Ground fault circuit interrupters work by monitoring the current flow in the circuit and detecting any imbalances between the hot and neutral conductors. If an imbalance is detected, indicating a potential ground fault, the ground fault circuit interrupter will quickly trip the circuit, cutting off power and preventing electrical shock. The NEC specifies the locations where ground fault circuit interrupter protection is required, and it's important to consult the latest edition of the code to ensure compliance. In general, all receptacles within 6 feet of a sink or other water source in a laundry room should be ground fault circuit interrupter protected. This can be achieved by installing ground fault circuit interrupter receptacles or by using a ground fault circuit interrupter circuit breaker to protect the entire circuit. Let's further discuss the specifics of grounding and bonding in subpanels. Grounding and bonding are essential for electrical safety, ensuring that metallic parts of the electrical system are at the same electrical potential. This minimizes the risk of electrical shock and provides a path for fault current to return to the source. In a subpanel, the grounding electrode system is connected to the subpanel enclosure in the ground busbar. The grounding electrode system typically consists of ground rods, ground plates, or other approved grounding electrodes. The number and type of grounding electrodes required depend on local codes and the specific conditions at the installation site. The grounding electrode conductor, which connects the grounding electrode system to the subpanel, must be sized according to NEC Table 250.66. The size of the grounding electrode conductor is based on the size of the ungrounded conductors feeding the subpanel. Bonding is the process of connecting metallic parts of the electrical system together to create a low impedance path for fault current. In a subpanel, bonding is required for the subpanel enclosure, the metal conduit or cable armor, and any other metallic parts that are likely to become energized. Bonding is typically achieved by using bonding jumpers, which are short lengths of wire that connect the metallic parts together. The size of the bonding jumpers is determined by NEC Table 250.102. C1. One critical aspect of subpanel wiring is the proper identification and labeling of conductors. All conductors must be clearly identified with their function, such as hot, neutral, or ground. This is typically achieved by using color-coded insulation or by marking the conductors with tape or labels. The NEC specifies the acceptable color codes for conductors, and it's important to follow these guidelines to avoid confusion and ensure safety. For example, the hot conductor is typically black, the neutral conductor is white, and the ground conductor is green or bare. In addition to identifying the conductors, it's also important to label the subpanel itself. The label should indicate the voltage, amperage, and the source of power for the subpanel. This information is essential for troubleshooting and maintenance purposes. The label should be permanently affixed to the subpanel and should be legible. Let's delve into the requirements for overcurrent protection in subpanels. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are essential for preventing damage to equipment and minimizing the risk of electrical fires. In a subpanel, each circuit must be protected by an overcurrent protection device that is properly sized for the ampacity of the conductors. The ampacity of a conductor is its current carrying capacity, and it's determined by the size of the conductor, its insulation type, and the ambient temperature. The NEC specifies the ampacity of various conductors in Table 310.16. The overcurrent protection device must be rated to interrupt the available fault current at the subpanel. The available fault current is the amount of current that would flow in a short circuit, and it depends on the impedance of the power source and the wiring. It's important to consult with a qualified electrician to determine the available fault current at the subpanel and select overcurrent protection devices that are rated to interrupt that level of current. In addition to protecting the individual circuits in the subpanel itself must be protected by a main overcurrent protection device. The main overcurrent protection device is typically a circuit breaker or a fuse that is located at the main panel or at the subpanel itself. The main overcurrent protection device is sized to protect the subpanel's feeder conductors, which are the conductors that supply power to the subpanel from the main panel. The size of the main overcurrent protection device is determined by the ampacity of the feeder conductors. When selecting wiring methods for subpanels, several options are available, including conduit, cable, and wireways. The choice of wiring method depends on the specific application and the local codes. Conduit is a rigid or flexible tubing that is used to protect and route electrical conductors. Conduit is often used in exposed locations or in areas where there is a risk of physical damage to the conductors. Cable is a factory assembly of two or more conductors that are insulated and enclosed in a protective jacket. Cable is often used in concealed locations or in areas where conduit is not required. Wireways are metal troughs or channels that are used to support and protect electrical conductors. Wireways are often used in industrial or commercial applications where there are a large number of conductors. When selecting a wiring method, it's important to consider the ampacity of the conductors, the environmental conditions, and the local codes. The wiring method must be suitable for the intended use and must be installed in accordance with all applicable electrical codes and safety standards. Let's discuss the importance of proper workmanship in subpanel installations. Proper workmanship is essential for ensuring the safety and reliability of an electrical installation. This includes following all applicable codes and standards, using high-quality materials, and taking care to avoid damage to the conductors and equipment. When installing conductors, it's important to avoid overbending or kinking the wires. This can damage the insulation and reduce the ampacity of the conductors. The conductors should be properly supported and secured to prevent them from sagging or rubbing against sharp edges. When making connections, it's important to use the correct tools and techniques. The connections should be tight and secure, and they should be protected from corrosion. All unused openings in a subpanel enclosure should be closed off with appropriate plugs or covers. This prevents the entry of dust, moisture, and insects, which can damage the electrical components. The subpanel enclosure should be securely mounted to a wall or other support structure. The mounting hardware should be suitable for the weight of the subpanel and the type of wall or structure to which it is being attached. After the subpanel is installed, it's important to inspect it thoroughly to ensure that everything is properly connected and installed. This includes checking the tightness of all connections, verifying the polarity of the conductors, and testing the operation of the overcurrent protection devices. Any deficiencies should be corrected before the subpanel is energized. Finally, it's important to maintain accurate records of the subpanel installation. This includes documenting the size and type of conductors, the size and rating of the overcurrent protection devices, and the location of the subpanel. These records will be helpful for troubleshooting and maintenance purposes in the future. Let's further discuss the specific requirements for laundry room outlets. Laundry rooms have specific requirements for electrical safety due to the presence of water and the potential for electrical shock. In addition to the dedicated 20 amp circuit for the clothes washer, there are other requirements for receptacles in laundry rooms. All receptacles in a laundry room that are within 6 feet of a sink or other water source must be ground fault circuit interrupter protected. This requirement is intended to protect against electrical shock hazards in damp or wet locations. Ground fault circuit interrupters work by monitoring the current flow in the circuit and detecting any imbalances between the hot and neutral conductors. If an imbalance is detected, indicating a potential ground fault, the ground fault circuit interrupter will quickly trip the circuit, cutting off power and preventing electrical shock. The ground fault circuit interrupter protection can be provided by using ground fault circuit interrupter receptacles or by using a ground fault circuit interrupter circuit breaker to protect the entire circuit. Ground fault circuit interrupter receptacles are typically installed in place of standard receptacles, and they have a test button and a reset button. Ground fault circuit interrupter circuit breakers are installed in the electrical panel, and they protect the entire circuit from ground faults. In addition to ground fault circuit interrupter protection, laundry room receptacles must also be tamper-resistant. Tamper-resistant receptacles have a built-in shutter mechanism that prevents children from inserting objects into the receptacle slots. This requirement is intended to protect children from electrical shock hazards. Tamper-resistant receptacles are required in all new construction and in any replacement receptacles in areas where children are likely to be present. The receptacles in a laundry room must also be properly grounded. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers to trip and clear the fault. A properly grounded receptacle will have a grounding terminal that is connected to the grounding conductor in the electrical circuit. The grounding conductor is typically a green or bare wire. When installing laundry room receptacles, it's important to follow all applicable electrical codes and safety standards. This includes using properly sized wiring, grounding the receptacles correctly, and providing ground fault circuit interrupter protection where required. Let's discuss the importance of regular electrical inspections. Regular electrical inspections are essential for ensuring the safety and reliability of an electrical system. Electrical systems can deteriorate over time due to wear and tear, corrosion, and other factors. Regular inspections can help identify potential problems before they become serious hazards. During an electrical inspection, a qualified electrician will visually inspect the electrical system, test the operation of the overcurrent protection devices, and check the grounding system. The electrician will also look for any signs of damage or deterioration, such as cracked or broken wires, loose connections, and corroded components. If any problems are found, the electrician will recommend repairs or replacements. It's important to schedule regular electrical inspections, especially in older homes or buildings. The frequency of inspections will depend on the age of the electrical system, the environmental conditions, and the type of occupancy. In general, it's recommended to have an electrical inspection at least every 3 to 5 years. In addition to regular inspections, it's also important to be aware of the warning signs of electrical problems. These signs can include flickering lights, tripped circuit breakers, warm outlets or switches, and burning odors. If you notice any of these signs, it's important to contact a qualified electrician immediately. Ignoring electrical problems can lead to serious hazards, such as electrical shock and fire. Let's summarize the key points regarding subpanel wiring and laundry room outlets. When installing a subpanel, it's crucial to avoid splicing the neutral and ground wires in accessible junction boxes. This helps maintain the integrity of the grounding system and prevents potential code violations. The feeder wires should be run continuously whenever possible, and if splicing is necessary, it must be done using a listed splice kit in a concealed location. The equipment grounding conductor plays a vital role in providing a low impedance path for fault current, and it should be properly sized and connected. The neutral and ground conductors must be separated at the subpanel to prevent circulating currents. In laundry rooms, a dedicated 20 amps outlet is required for the clothes washer to ensure adequate power and prevent overloading. All receptacles within 6 feet of a sink or other water source must be ground fault circuit interrupter protected to minimize the risk of electrical shock. Tamper-resistant receptacles are also required to protect children from electrical hazards. Proper workmanship is essential for all electrical installations, including subpanels and laundry room outlets. This includes following all applicable codes and standards, using high-quality materials, and taking care to avoid damage to the conductors and equipment. Regular electrical inspections are crucial for ensuring the safety and reliability of an electrical system. These inspections can help identify potential problems before they become serious hazards. By following these guidelines, you can help ensure a safe and compliant electrical installation for your subpanel and laundry room outlets. Remember to consult with a qualified electrician if you have any questions or concerns. Electrical work can be dangerous, and it's always best to leave it to the professionals.